And we're live.
Yeah, welcome everyone. My name is Tekraj Chetri and I'm a founder of Care Nepal and a postdoc at MIT. Today I'll be monitoring this session and I'm happy to present our speaker, Joakim. Let me give you a brief introduction of Joakim. Joakim is a knowledge graph lead at Capgemini, Sweden. He has tons of experience working with knowledge graph. Is, he has worked with fraud detection, and that's what his presentation today is about. He has experience in different knowledge graph stacks like RDF, all, and he's also got tons of experience with other programming languages like Haskell, C++. To basically sum up, he has wide range of experience both in software development, developing new algorithms, using knowledge graph, and happy to invite Joakim up to you.
Thank you. And thanks for the introduction. So I'm here today to talk about how we can use knowledge graphs to detect fraud or fraudulent behavior. And I just go a little bit more, just a bit of background. So my name is Joakim Nilsson, as Tech said here. I'm working as a senior consultant and knowledge graph lead for Capgemini Sweden. And I've helped clients both in Sweden and abroad and in private and public sector to navigate knowledge graph projects. I've also been able to present in things like this and for a lot of clients and internally to upskill our current staff. We're a global company with over 300,000 consultants. So it's important to spread the knowledge of knowledge graphs. And we've seen a lot of interest in knowledge graphs, both internally and from our customers. And this year has been a lot of focus on fraud detection from our clients, a lot of requests talking about that. And I'm based in a city called Malmö. It's south of Sweden. It's right to the border of Denmark, best known as the town where our football star Zlatan Ibrahimovic grew up. And it's also the birthplace of Neo4j, leading graph database vendor that I also worked for as a field consultant for a short while. And since the last almost 4 years for Capgemini. My background is I started with studying accounting and took some math courses. Started working as an accountant, and then those my interest in mathematics grew to a bachelor's degree, and then I took a master's degree in mathematics where I studied graph theory. So that was something that will be beneficial for me later in my career. In the last year and a half, I've been involved in a knowledge graph project where we are trying to detect fraud using knowledge graphs. And as I said, it's been a lot of interest around this area lately. And this,
Joakim, a small comment. We'll be taking questions at the end, and the presentations would be 20 to 25 minutes. So audience can post your questions in the comment, and I'll be taking over it. Please.
thank you. So this is an image I usually have for presentations to illustrate the power of knowledge graphs. That the challenge today is many times not the lack of data a company has, but rather lack of understanding how to derive insights from that data. By organizing vast amounts of unstructured and structured data into interconnected relationships, knowledge graphs can provide a clearer context and deeper understanding of the data you have. And I'll cover these topics today. First, we can start off with traditional ways of doing fraud detection. Now, today, significant amounts of money intended for the welfare system are lost to welfare fraud, undermining the social contract that binds society together. Welfare fraud drains resources from the most vulnerable, erodes public trust, and strengthens criminal networks, creating a vicious cycle. And authorities are working to combat these issues, but traditional tools struggle with fragmented data and often focus on isolated data points rather than complex, evolving patterns of fraud. The data involved is scattered across multiple platforms and formats, making it difficult to assemble a clear picture. What may appear as isolated data points are often part of a larger organized uh, crime network, but conventional methods fail to connect these dots efficiently. And traditional expert systems are highly effective at recognizing patterns based on predefined rules and structured inputs. However, these are limited to identifying only what they have been programmed to know, making them less effective at spotting new and evolving fraud tactics. And they rely on structured data and struggle when faced with unstructured sources like transactional records, emails, or social media interactions. Such data often holds key clues to fraudulent activity, but is difficult for old systems to process reliably. The graph databases offer a groundbreaking solution by mapping relationships in unstructured data, revealing these intricate connections and visualizing patterns that were previously hidden. These systems excel at handling dispersed data and can adapt to new fraud scenarios in real time, providing authorities with a clearer, broader view of complex networks. This innovation allows authorities to stay ahead of fraudsters with scalable systems that can learn and evolve. By implementing this technology, we can better predict and protect the welfare system and restore trust and ensure that the resources are going to those who truly need them. And this is for the welfare system because that's what have been working mostly with, but the same can be done for finance, banking, insurance, or any kind of fraud, really. And I assume most of you know what knowledge graphs are, but just for those of you that might not have a very good understanding, then just a brief recap. So this is something a quote I like there, that increasingly we're learning that you can make better predictions about people by getting all the information from their friends and their friends of friends than you can from the information you have about the person themselves. And this is something you can think about, for example, your LinkedIn accounts. If you go in and look at my LinkedIn connections, you will see that probably 90% of them are working within the IT field. Many of them within knowledge graphs or Gen AI. A big portion of them have worked for either Capgemini or Neo4j. So it wouldn't be that hard to guess that I'm an IT guy working for either of those companies. If you instead go into Facebook or Meta, then you might have more personal information about the connections that would indicate where you grew up or where you went to school. And in Sweden, a couple of years ago, there was a TV show that tested this theory. Was around the world in 6 steps. So they put two celebrities in a remote village, I think in Botswana, and then in 6 connections they should make themselves find themselves to Gordon Ramsay and other celebrities, and they usually succeeded by going to a friend of someone. Maybe in that remote village they had a friend studying at the university. That friend at the university had a professor who knew someone in London, might know someone in the restaurant business, and so on. So we can get quite far in just a couple of steps, showing how interconnected we really are. And then here about some information from Gartner that has identified the graph technology as the game changer for companies looking to integrate and automate data and processes, with more than 80% of such projects hinging on graph capabilities already by next year. So for those of you that are not involved in knowledge graphs yet, then it's a really good time to start getting up to speed with this technology, because it's something that's really gonna grow a lot in the next coming years, and we're seeing a lot of interest in this technology at the moment. It is under the AI umbrella as well, within areas such as knowledge representation, reasoning, ontologies, and logical deductions. And graphs are truly everywhere. We see it from road networks, where you can run algorithms to predict shortest paths between stations. I saw in one conference where they mapped out the whole subway system in London, and then they simulated by shutting down one stop and seeing how they can reroute the traffic. We're in social media, like in LinkedIn recommendations. We have in the power industry, for example, with planned maintenance, and we have it a lot of in data data governance and metadata, for example. And the key difference here is how we store the data, and that we don't store it in rows and columns, but rather in as a data points and nodes, and then draw relationships between those data points, where we can also enrich it with the labels and properties, and making us or making an organization to focus on what is important in the data, which is the relationships. And even though we have a lot of interest in this area right now, with knowledge graphs or graph theory is far from new. Started here with the famous problem of the 7 bridges of Königsberg in today's Kaliningrad, not that very far from where I'm sitting, where Leonhard Euler was tasked with solving the problem of if you could traverse all these 7 bridges once, but only once, and to derive the conclusion, he started working on a part of mathematics that later grew into graph theory. So it's nothing new, but the interest in the area is really increasing. And one way of detecting fraud is through graph data science, which is something that I have some experience with. And when we're talking about knowledge graphs and graph databases, my experience is mostly within Neo4j. But there are, of course, the RDF graphs as well. But when working with Neo4j, we have around 50, 60 different graph algorithms that we can use as a plugin that is real efficient. And one case famous case where this was done was a couple of years ago, or 7-8 years now. Time flies. The Panama Papers, where this group of journalists got a hold of this huge document leak from a law firm, and they teamed up with Neo4j to go through and make sense of all the data they got. And we see how powerful knowledge graphs really are in finding relationships and making sense of data. So, as they say here, one of the main challenges facing a journalist is sifting through massive amounts of information to discover the truth and expose the lies. And with this technology, they made connections between activities and entities that otherwise would have been missed. And this resulted in huge scandals. Several politicians and athletes, sports stars, were caught in this. I think even the president of Iceland has had to resign as a result of it. And it was big. It was 840,000 nodes, and it's not that big, but it's it really led to a lot of effects from this. And then Some of the algorithms here that I've been working with that are available as a plugin here is community detection algorithms, where we can find clusters or groups of highly interconnected nodes in a graph. In fraud detection, this can help identify suspicious groups or rings of users, accounts, or transactions that interact more frequently with each other than with the general population. And fraud rings, they often show up as tightly connected communities. Can also use graph embeddings as a way to represent nodes in a multi-dimensional space where the distance between nodes reflect their similarity in the graph. You can use these embeddings as a feature in machine learning models to detect anomalous behavior or cluster nodes based on their embeddings. Where you can use like the NodeTVEC, for example, algorithm can be used there. It's useful in fraud detection because it can help spot anomalies or clusters of similar behaviors. We can use link prediction algorithms to estimate the likelihood of a new relationship or transaction in that case between nodes in the future. In fraud detection, you can use this to predict suspicious or unusual interactions between entities. For instance, if an account suddenly starts transacting with suspiciously high number of new accounts, this could signal fraud. Um, Centrality algorithms help identify important nodes in a network. In fraud detection, important nodes or high centrality nodes might represent suspicious accounts that are controlling a large part of fraudulent operation, such as a payment mule or a coordinator. And as an example, here we can have that an investigation begins with an alert that signals unusual transaction across several bank accounts. To dig deeper, we then can load in the transactional data in our graph, where nodes represent accounts and edges represent transactions between the accounts. Using, for example, Louvain community detection algorithms, we can uncover several tightly knit groups of accounts that are more connected to each other than to the wider banking network. And of these communities, one stands out, a cluster of 50 accounts transferring small amounts of money between themselves at a high frequency. At a first glance, they can seem harmless, but tight interconnectedness signals that these accounts might be part of a coordinated operation, like a fraud ring, for example. They can use the node-to-vec graph algorithm to transform the graph into a multidimensional space, with each account gets an embedding that captures its transactional behavior and its relationship with other accounts. By plotting these embeddings, you can notice something here that the accounts in the suspicious community exhibit very similar embeddings, meaning that their behavior is nearly identical. And this clustering in the embedding space suggests that these could be acting as in a coordination with each other, possibly executing a money laundering scheme. And with these insights, then we can move to link prediction. And if the group of accounts is indeed engaging in fraudulent activities, they might expand their operation by creating new connections with unsuspecting accounts. And we can then look for common neighbors and similarity between nodes. And the algorithm predicts a high likelihood that some accounts in the cluster will start making transactions with new accounts that were not previously part of the fraud network. And using these predictions, it can flag emerging relationships for closer monitoring. Link prediction can help us stay ahead of fraud by predicting next set of accounts that might be drawn into this suspicious ring. You can use between centrality and PageRank to find the most influential accounts in a network. Between centrality can show us which accounts act as bridge nodes between different parts of the network, while PageRank can highlight the accounts that receive the most attention from other users. Um, and then we have another approach that we're starting to look into more, and that I have co-authored an article that will be released early next month about using hybrid AI for fraud detection. Um, and this is a very interesting area where we today depend on structured knowledge to navigate complex systems. However, this process of creating structured knowledge introduces certain challenges. Traditional expert systems are precise but limited to detecting known patterns and can struggle with unstructured data. LLMs excel in natural language processing, capturing subtle signals in messy data but lack structured reasoning. So to combine this with the LLM's ability with expert systems reliability, we can create a stronger fraud prevention framework, integrating weak signals into actionable insights. And this is something that we haven't used, or I haven't used in a project yet. So, but it's something that we're exploring and hope to be able to use in the future as well. Um, and yeah, so to sum it up, by using by leveraging knowledge graphs, if they're property graphs like Neo4j or RDF graphs, it can be a huge potential for uncovering fraudulent behavior within any kind of sector. I've had interest from many kinds of sectors of using knowledge graphs for detecting fraudulent behavior. And by mapping intricate connections, knowledge graphs can expose hidden fraud rings and evolving threats, allowing authorities to detect and respond to these sophisticated schemes, as they often are, because it's not like looking just for needle in haystack, because these ones are actively trying for you not to connect them. So it's not always easy, but with a knowledge graph, we can come a long way. And that's it from my presentation.
Yeah, thank you, Kim, for the wonderful presentations. And if there's any question, I'm happy to take. I do not see anything on the comment. Definitely interesting. And I being working with knowledge graph, I can say, yeah, knowledge graph is evolving and it's being adapted in different industry, both in research as as well as in the large industry. I have
Mm.
few questions. Since there are no other questions from the audience, I think I can get clarifications on the queries that I may have. Oh, we got one. So there's a question. How does one get started with the development of knowledge graph for anti-fraud activities? It's a wonderful
Yeah,
question from Joakim.
good question. Yeah. So, from my experience, usually when you go to a client that is interested in leveraging knowledge graphs for this use case, they have people that with a lot of domain specific knowledge that we first sit with and try to understand their internalized knowledge that they have, even though it might be in an as many cases in an Excel sheet with what is the risk in our case, but to get that understanding first, and then trying to map that into our knowledge graphs, so we can run these algorithms on because there is a lot of internal knowledge that they have. It's just it's not used in the right way. So a lot of domain specific knowledge for sure goes into this, and a lot of modeling work goes into it as well. It's not something that we build overnight. It takes time.
Right. Uh, I have a question connecting to what you've just said. You said like there's a lot of domain knowledge in Excels and other file sources. So how do you see this large language model? I know you have mentioned in your presentation that you have just started exploring, but how do you say, even though you haven't worked extensively on it, having known the capabilities of large language model, what way you see that it will help, and what might be the challenges that you, based on your experience dealing with it manually?
Yeah, I mean the challenge, yeah, the challenge for sure is a lot of it. Um, because it's hard, inherently hard to trust a large language model, as we know. But using a knowledge graph, then we can reduce the hallucination from it. So in our paper that we have, we just theorized it. We haven't, as I said, used it in a project yet, but we thought of using multi-agents, for example, because when you're working with fraud, you collect data from a lot of different sources, and then we bring them together into the knowledge graph, and then we were exploring with multi-agents working together on this, and one, especially with the closed world assumption that we have one agent doing only one thing, one agent fetching data from one source, and another one checking, cross-referencing, or having different tasks. But to have an agent only doing one thing and then closed world assumption so it doesn't hallucinate, that's something that we were theorizing with here, and I think we'll see a lot of it, a lot of developments in that area, because it's the interest for it has been really taken off with Gen AI, LLMs, and how we can incorporate it. And that is one way that we have explored, but we haven't done it in a project yet. So far in projects, we're working with knowledge graphs, and usually not that much with Gen AI when it comes to fraud.
Yeah, I definitely agree with you regarding the evolving interest in multi-agent systems. I'm
Yeah.
also working on it, again
Mm.
using knowledge graph.
Yeah,
So we'll
it's
be
very.
taking two more questions. Oh, I already saw one. So what are the advantages of knowledge graph over existing solution? That's a
Yeah, so
wonderful question. I think many people have difficulty understanding what value graph brings compared to existing relational databases and other file formats.
mm, yeah, so the main difference is that within knowledge graphs, we treat the relationship as first class citizens. So it's something that's inherently there in our data, and you get so much better overview of your data, and as often as in fraud cases, networks, and it's very beneficial to be able to visualize networks and see how different persons or different companies are connected to each other. And to do that in a knowledge graph is very easy. To do that with tables and columns, it's not that intuitive for the human to see it like that. And if you have a lot of data, then it's also very fast to traverse the data and do queries within a knowledge graph, much faster than what we can do using relational databases. So it's both a performance issue, but it's also that it's so much easier to find the relationships that we don't see it when we just use Excel sheets or when we use rows and columns.
Yeah, one point that I could add, again, borrowing from your presentation, is that the intuitive visualization and involved by like inherently is
Mm,
a graphical representation. If you see your connection with friends, right?
mm,
Having said that, I have one last question. Since people who do fraud, they try to avoid like detection, right? Their patterns evolve. So how do you deal with such kinds of situation, the evolving pattern and the dynamic data that come in,
Yeah, I mean that's
and
really
how knowledge graph help in this case.
yeah. I mean it is a really tricky thing, of course, because they are doing their best to avoid getting caught. Um, the thing we can use with knowledge graph is still that they have some connection, and even though they might not have a connection to their own accounts, they have connections to intermediary nodes that could link it to their accounts and so on. So, but of course, there is a challenge with evolving patterns and fraudsters always trying to be one step ahead. But we are coming a long way by using knowledge graphs to to find these relations that they still have and must have.
Okay, I see there's one more question. I think it would be wise to take. So it's a question from Satya. The question is, how much is knowledge graph have to do with the processes as compared to data?
I didn't see it. Can you? No, there. I don't really understand that.
I think that he's asking how involved are knowledge graphs
Yeah.
as related as data? Like data and knowledge graphs, how do they compare with modeling the process and transformation of information?
Yeah, I mean, so well, when it comes to modeling, that is something that if that's what you mean here, like we put a lot of work into how to model our graph, our knowledge graph to reflect the data we have, and it's both for having the understanding of the data itself, how it's connected, because you need a lot of domain specific knowledge, which is why we always team up with subject matter experts from these clients that we go to, because we don't always know ourselves how the data looks, or how we're not experts in all fields that we're working with. So we always have someone with us that can explain how their domain basically. And then you also have performance issues. If you don't model your data in the correct way, then you can have some bottlenecks, and you can slow your queries, and that's something that we put a lot of work into. So it's that is something that takes a lot of time sometimes to get right when you have, especially when you have a lot of data. When you start out, then you can kind of get away with a lot of things. But then when you really load in a lot of data, millions of nodes and relationships, then you notice if you haven't modeled it efficiently, then you're going to run into troubles.
Well, thank you both for the wonderful presentation, and thank you, TechRaj, for moderating the session. We're going to have a brief intermission, and then we're going to be back with Peter Felaschini and Michael Borelli. So we'll see you soon, and yeah.
Thank you.
Fine.
Bye.